Embryo transfer is one of the most successful methods for producing a high potential calves from both in vivo and in vitro embryos, resulting in enhanced herd genetics. Although embryo generation and transfer techniques are more time-consuming than artificial insemination, they are routinely used by repeat breeders with a steady pregnancy rate. However, uterine manipulation and endometrial injury are inescapable throughout the embryo transfer procedure, raising the probability of an inflammatory response and prostaglandin secretion. As a result, the embryo transfer operator should pick a potential recipient and conduct embryo transfer without creating unnecessary injury to the uterine horn. The use of a synchronizing program capable of inducing ovulation, corpus luteum development, and the resulting hormonal changes in the receiver enhances the success rate of embryo transfer. Cows with high circulating progesterone levels before super or single ovulation had a higher proportion of high-grade embryos on the day of recovery than cows with low progesterone levels. The current research focused on determining the factors that enhance the pregnancy rate of embryo transfer, particularly with regard to the receiver. Researchers gathered data on corpus luteum size and progesterone concentration the day before embryo transfer using two synchronization methods and investigated the impact of those measured parameters together with parity and season on conception rate.
This is the all materials that will be used in this research. Total 90 Holstein Friesian cows that raised on a freestall farm in Korea. For medical treatment and sample collection will be done in Farm Animal Medical Teaching Hospital. From November 2017 to October 2022, around 44 over 90 cows will be used in synchronization programs with two types of protocols that are conventional and J-Sync protocols. The details methods is provided in the slide above. The recipient evaluation method will be continued with 116 over 165 recipient candidates will be involved. Corpus luteum size was evaluated on the day before embryo transfer using B-mode ultrasonography and P4 concentration in plasma collected from coccygeal blood vessel measuring by fluoroimmunoassay. Then evaluate the corpus luteum size in increments 0.5 cm. Next, recipients will group according to corpus luteum sizes and P4 levels. After that, embryo transfer has been done by rectal palpation of uterus and ovaries by trained veterinarian and will be used frozen embryo. The embryo was thawed and transferred into the upper one-third of the uterine horn. Then, pregnancy was confirmed 4 days after fixed-time embryo transfer (FTET) using B-mode ultrasonography. Lastly, statistical analysis will be done to analyze all the data provided. Z-test was conducted to evaluate in embryo transfer service rate and pregnancy rate according to synchronization methods, parity of recipients and seasons. Differences in P4 levels in corpus luteum sizes between selected and unselected and pregnant and unpregnant recipients were analyzed with the Mann-Whitney rank sum test. Multiple logistic regression analyses were used to predict pregnancy rate using ET-related variables. Synchronization methods, parity of recipient, season, corpus luteum size and plasma P4 levels. Statistical analysis was conducted using sigma plot 12.5 and significance was set at P less than 0.05.
As for the result, service and pregnancy rates according to synchronization method, parity and season. Service rate did not differ significantly between synchronization method CONV versus JSYNC, parity heifer versus cow, or season September to February versus March to August. Pregnancy rates did not significantly differ between synchronization method, but were significantly higher in heifer when embryo transfer was performed from September to February. For the recipient evaluation based on corpus luteum size and plasma progesterone levels, selected recipients show a larger CL sizes and higher P4 concentration on average, but the differences were not statistically significant and the average P4 concentration in pregnant recipients was higher than in non-pregnant recipients, although this difference was not statistically significant. For pregnancy rates based on CL size and P4 level, pregnancy rate was lower in the CL1 group, less than 1.5 cm compared to the CL2 group that are more than 1.5 cm but not higher than 2.5 cm. No statistical difference in pregnancy rate was observed based on P4 levels, but the P4 level in group 2 were more than 2.0 ml and less than 4.0 ml showed a higher pregnancy rate. Embryo transfer related factors influencing pregnancy rate. The priority of recipient and the season of ET significantly influence the pregnancy rate. Synchronization method and recipient evaluation CL sizes and P4 level were not predictive of pregnancy rates. Logistic registration analysis. Logistic registration analysis show that priority and season significantly influence the pregnancy rate, while synchronization method, CL sizes, and P4 level did not show a significant impact. Ultrasound evaluation on the day before ET. The ultrasound image on the day before ET were used to assess the suitability of recipient candidate. The evaluation results, including CL size and P4 level, were not communicated to the operator on the day of ET. Ultrasound image or CLs were recorded the day before ET. The operator performed ET without knowledge of the evaluation results. Candidate with poor ovarian structure were excluded. The representative figure of selected recipient was shown according to the pregnancy and CS size as the picture you can see here.
Embryo transfer is the fastest method to change genetic abilities and boosting productivity in cattle. It is also provide reproductive treatment and pregnancy opportunities in dairy and beef cattle. It is important to increase pregnancy success rates because of the higher expenses and longer time spent on embryo transfer compared to artificial insemination. Two CIDR-based user synchronization protocols, which are CONVI and GSync, were applied for pre-treatment of embryo transfer, where both methods effectively induce uterus and corpus luteum development. The estradiol treatment induced dominant follicle regression and new follicular wave development under conditions maintaining progesterone concentration through CIDR insertion. The study found that a larger crown size and higher progesterone level on the day of embryo transfer indicate high reproductive performance in cows. However, the correlation between corpus luteum size and progesterone was not significant. The pregnancy rate with a functional corpus luteum depends not only on the size but also on the shape of the crown and the presence of a cavity, which also differs according to priority. In addition, it is necessary to analyze the changes in follicular and uterine function in response to circulating progesterone to investigate the pregnancy rate with embryo transfer. There is also the limitation of this study is that the pregnancy rate was identified only by the corpus luteum size and progesterone concentration the day before embryo transfer, without considering other variables such as uterine environment and milk production.
In summary, embryo transfer is a reproductive strategy used to improve desired genetic feature within a herd or flocks. By using this technique, embryos are taken from genetically superior donor female and transferred to recipient female, who then carry and give birth to the progeny. Embryo transfer played a critical role in several domains, including conservation, livestock, genetic improvement, fertility problem, and the advancement of knowledge regarding embryonic development. The procedure's success has broad implications in this field.